Hi students, today we're going to be learning about similar triangles. So we're going to be comparing the parts of a triangle into triangles that are similar in size. Now similar means that the triangles are the same shape, their angle measures are the same, but their sides are different. So basically same shape but in a different size. And so what we're going to see is that their sides are what we call proportional. So if I'm looking at these triangles, triangle DEF is similar to triangle ABC. That's what this symbol right here, this squiggly line means similar. Now when we're looking at these, we need to match up the corresponding sides. And so we do that by looking at the letters, and that tells us which angles correspond. So because A is located first and D is located first, that tells us that this green angle right here, 65 degrees, corresponds to 65 degrees. And then we next have E and B. So that means that angle B and angle E are corresponding. They're the same measure. So the side between those two, this side here, AB, corresponds to side C. Side AB corresponds to side DE. The pink sides are going to have a proportional relationship with each other. Also, this bottom side between 60 degrees and 20 degrees, 65 degrees and 20 degrees, 65 degrees, 20 degrees. The purple sides are corresponding sides, so they're going to have a proportional relationship to each other. And then finally, the third side, the yellow sides, are going to have a proportional relationship to each other. And we're going to be able to use those proportional relationships to identify or find missing angle measures or missing side lengths. So let's take a look at some of these. So looking at the first two triangles, we want to say whether or not the triangles are similar. So when we're checking to see if they're similar, we're looking to see are all of the sides corresponding. So is there an angle in the first shape that matches up or is the same measure as an angle in the second shape? So if I'm looking here, 75 degrees matches up with 75 degrees. 50 degrees matches up with 50 degrees. So since two of the angles match, we know that all three angles have to add up to 180 degrees. So that tells us that the third angle must match because they would need the same value in order for the three angles to add up to 180 degrees. Looking at the next two triangles, I can see that I have a 63 and a 63. But now at this point, I have a 54 and a 63. So what I need to do is I need to find the value of x and the value of y before I can continue comparing them. So for the first triangle, I would have 54 plus 63 plus x equals 180. So I want to find the measure of that third angle. So 54 plus 63 is 117 plus x equals 180. I would subtract 117 on both sides, and I get x equals 63 degrees. So this angle right here is 63 degrees. Now I'm going to do the same thing for y. So I have 63 plus 63 plus y equals 180. So I'm going to add those together, and that gives me 126 plus y equals 180. So I'm going to subtract 126 from both sides, and I get y equals, oops, sorry, my pen cut out there, y equals 54 degrees. So now I can continue comparing. I already matched up the first angle. I see that I have a second angle that's 54 And then I have a third angle, 63 and 63. So I could say, yes, these are similar because I can match up each of the corresponding angles. Now, let's look at this next example. So now I'm going to start talking a little bit about the corresponding sides. So when I'm looking at this diagram, I can see I have two triangles. I'm going to call this triangle 1 and this triangle 2, just so it's easy to distinguish. Now, I want to say whether or not these triangles are similar. So I need to go through everything that we've learned about triangles and angles and sides and start looking at that. Now, what I do notice is that angle E is a 90-degree angle. So I know that they each have a 90-degree angle, angle E and angle B. The next thing I notice is that I have a pair of vertical angles right here. So I have the vertical angles that are congruent. So I have a vertical angle, I'm going to call that my green angle, and then I have my 90-degree angle. Now, because two of the angles are the same, that means that this third angle, this yellow angle down here and this yellow angle up here, must be the same. Because when I add the 90 degrees plus the green angle, I'm going to need a certain value to get up to 180. And the other triangle, triangle 1, has the same thing. It has 90 degrees plus the same value for green, so that means the two yellows must be the same. So these are similar. Now, when they're similar, corresponding sides are what we call proportional. So that means that the length of this side right here, which is 40, corresponds to the side that is also between the 90-degree angle and the green angle. So this here, 50. So when I'm comparing these, I'm going to set up a ratio that compares triangle 1 to triangle 2. So in triangle 1, the pink side is 50 feet. In triangle 2, the pink side is 40 feet. Okay, now I'm going to be solving for x. And so this x side, the green side, is between the 90-degree angle and the yellow angle. So it corresponds to the green side over here. So in triangle 1, the green side is 60 feet. And so I'm going to solve for the matching length of side x. So because they're similar, they have a proportional relationship. So I can use proportions to solve this. So now to solve the proportion, I would use cross products. So 40 times 60, 2,400, equals 50 times x is 50x. I'm going to divide by 50. And I get x equals 48, and my units are feet. So the missing side length is 48 feet.